Hi there, this is Don Tait, Senior Analyst within Omdia Cybersecurity Group. The title of my presentation today is Continuous Authentication All It's Cracked Up to Be? After this presentation, I will be available for Q&A. The agenda for today's presentation is as follows. We will start off with a brief introduction on continuous authentication, or CA, together with a definition of what it is. Then we'll look at some of the market dynamics around it. This includes market benefits, the size of the market in terms of dollar revenues, trends, and a use case for CA in banking. On the flip side, we will look at some of the challenges for CA in the areas of biometrics and regulatory issues. Finally, we'll draw some conclusions and recommendations on this interesting area. Even before the pandemic forced millions of knowledge workers worldwide to work from home, it had long been a truism that identity had become the new perimeter. Increasing adoption of cloud computing and worker mobility had already reduced the effectiveness of traditional perimeter security, with so much corporate activity taking place outside it. The castle and moat paradigm of yesteryear for cybersecurity is no longer operative, and in this new scenario, identity, whether of a human user or thing, becomes even more critical for security than it was in the old world. In this sense, COVID-19 merely turbocharged a tendency that had been underway for several years. Identity has never been more important than now. The zero trust approach to security that has enjoyed increasing adoption in recent years has as its mantra, never trust, always verify. And one manifestation of that ethos in the identity, authentication, and access world is continuous authentication. It is imperative for defenders to monitor the activities of any person or thing they have allowed onto their organization's infrastructure. So, definitions of what is continuous authentication, or CA. CA is a method of identity confirmation on an ongoing basis. Instead of a user simply being logged in once, the authentication mechanism continues to re-verify the identity of the session user even after logging in. In this method, the computer continuously searches for the presence of tokens such as smartphone signal within the immediate proximity. If the token is no longer present, the computer will automatically lock. CA is implemented using machine learning, or ML, and a variety of factors, including behavior patterns and biometrics. Now let's look at some of the market dynamics for CA. We've highlighted three here, and we'll go through each in turn. First of all, we've got presence-based authentication. Detecting the presence of a user using a key, token, or smartphone for proximity scanning is a form of CA. The computer constantly scans for the presence of the key's wireless radio signal to continue verifying the user's presence. When the token leaves the vicinity of the computer, the machine locks. A limitation is that it requires the user to keep a token or phone with them. Secondly, we have biometric authentication. There are a multitude of biometrics, including iris, retina, face, fingerprint, ear shape, signature, finger geometry, finger pressure, voice, and hand geometry. There are obviously positives and negatives of each of these biometrics. For example, facial recognition devices can be used to make sure the verified user is still present and locking the session when the user moves away. Modern image and video matching algorithms can achieve high accuracy, but it's not a practical solution in circumstances such as a hospital, where masks or PPE gear are commonly used, as has been the case during the pandemic. Another area is voice authentication, and that can serve the purpose of CA as well, but it may introduce complications in a noisy environment. So therefore, there's pros and cons in each of these biometrics, and you have to think about the environment that it's going to be used in. And finally, we have behavior or activity-based authentication. Developing a behavioral model of the authenticated user over time can help with detecting non-conformal use of the computer. This can include typing, mouse movement, website activity to determine the presence. By building a user's behavioral signature, authentication software can then prevent access whenever real-time use of the computer starts deviating from the user's behavioral model. So what are some of the benefits of CA over static authentication? First of all, we've got dynamic security over one-time logins. One-time authenticated logins are like checking someone in at the gate. You don't know what they're going to do once they're inside the building. Static authentication methods are simply not robust enough to deal with ever-changing environments. A good CA solution will consider as many environmental and human factors as practical. Next, we have less reliance on people. Providing strong security throughout the entire session and accurately determining how to end sessions are key goals of CA. By not requiring any user interaction during CA, reliance on people to think about security is greatly reduced. Finally, less stress for administrators. Admins stress because their users make terrible decisions with regards to security. Users will avoid authentication-related tasks like the plague and find many ways of circumventing an administrator's security for little convenience. Now, it's also worth highlighting the overall size of the authentication market. Despite the global COVID-19 pandemic and economic downturn in 2020, the overall authentication market reached nearly $8 billion with a compound annual growth rate of 10.3%. This is projected to increase to around 12 billion by 2025. The pandemic resulted in a sharp increase in fraud attacks, with an increase in the number of home workers and acceleration of companies moving to the cloud. The proportional importance of CA is projected to increase during the next 5 years and will account for over 50% of the overall authentication market. This was sort of taken further by a recent survey conducted by Dark Reading in conjunction with Omdia. And if you look at the left-hand figure or image, it was found that 21% of respondents were already using CA, whilst a further 26 were planning to use CA in the next 12 to 18 months. It's quite an impressive number there. Furthermore, if you look at the right-hand image, behavior-based technology is projected to be the most popular type that respondents are planning to use in the next 12 to 18 months, with over 45% of responses. Another interesting thing from the one on the right was that biometrics is actually to decrease slightly. We'll look a bit about biometrics later on, but it has received a bit of bad press over the last year or so, but we can look at that in a bit. So let's look at a use case, and the use case that we're going to look at is CA in the banking sector. CA is a method of confirming a customer's identity in real time when they are in a banking session. Typically, this happens when a customer is using their mobile phone or desktop or an ATM. It takes place throughout the session, e.g. checking a balance, making a wire transfer, or adding a payee, etc. CA uses multiple streams of data to allow a risk engine to evaluate and recognize a customer's unique movements and patterns during the session. The customer doesn't notice that their location, device, environment, keyboard cadence are being compared to a profile of how they normally interact with their phone and their banking application as part of the user experience. Data can be collected from many different components of a customer session with their bank, which can be anything from how they interact with their mobile devices, such as swipe patterns, and keystroke dynamics to their location. The pandemic has resulted in a sharp increase in fraud attacks. CA helps reduce fraud because it goes far beyond verifying a customer's identity at login or when they're performing a transaction. Behavioral biometrics can be difficult for fraudsters to beat at this time because they provide continuous signals about the authenticity of the customer based on behavior. Machine learning algorithms can analyze very large amounts of transaction data that would be difficult and time-consuming for analysts to review. Algorithms look at customers' location, device, network, and other data. CA remains in the background as the customer does their banking, establishing a continuous risk profile for the session, which can change with each action by the customer or their device. Not only does this allow the financial institution to take real-time action when anomalies are detected, but also allows the bank to reduce friction for legitimate banking sessions. So, what are the main market challenges and regulatory issues for continuous authentication? We've highlighted 4 in this slide. First of all, device identity and security posture. Browsers increasingly try to protect end users from a privacy and ad tracking perspective. This makes it harder to identify what device a user is accessing browsers from. The ecosystem needs a standard to establish this context and integrate with the identity provider or IDP flow, enabling communication with the application backend in order to provide that device assurance. Next, we have session or token loss of signal and revocation. Currently, organizations may need to manage thousands of servers to manage application access, which isn't practical manually. Instead, they should enable a standard API surface area to manage authorization, server management, session revocation, and changes and device access. Next, we have session level controls. Session controls often get mapped to responses within a given application. To help scale this approach, there needs to be a link between the risk that changed and the appropriate security control to be enforced in the app. Shared signals and events. Sharing visibility of key events such as changes to account lifecycle or user attributes proactively protects it from threats. So let's have a look at some of the regulatory and acts that have an impact on CA. CA also needs to be mindful of relevant regulations and acts. Some people find continuous authentication and biometrics, in particular, an intrusive technology. With the advent of regulations such as GDPR and CCPA, there's an element of consent from customers and data minimization. I thought now is an important time just to sort of give a sort of quote on the definitions from GDPR and CCPA in relation to biometrics. For instance, the GDPR prohibits the processing of biometric data for the purpose of uniquely identifying natural persons. Biometric data is personal data resulting from specific technical processing relating to the physical, physiological, or behavioral characteristics of individuals, whilst if California CCPA specifically requiring businesses to safeguard biometric data and specifically cites biometric information as a type of personal information. Businesses must comply with all the CCPA's obligations in respect of any biometric information they collect, use, store, or share. It's important for everyone to be up to date with these regulations and acts. Otherwise, they'll get fined. So, what are the main conclusions and recommendations that we can make about continuous authentication? So from a conclusions perspective, the pandemic has resulted in a sharp increase in fraud attacks, with an increase in the number of home workers and acceleration in companies moving to the cloud. CA can be used to help reduce fraud attacks. also in regards to the entire session. Providing strong security throughout the session and accurately determining how to end sessions are key goals of continuous authentication. Reduces fraud. CA helps reduce fraud because it goes far beyond verifying a customer's identity at login or when they are performing a transaction. It is important to note that behavioral biometrics can be difficult for fraudsters to beat because they provide continuous signals about the authenticity of the customer based on behavior. Regulations. CA needs to be up to date on regulations such as GDPR and CCPA. So from a recommendations side, enabling CA. Vendors need to evaluate the data tools that are available in their products. CAU uses long-term confidential information to review access. Thus, a long-term approach is required to managing changes to these long-term sessions. Evolving to meet changing environment. Enterprises and identity providers or IDPs need to evolve to handle real-time authentication and authorization, enabling the use of best-of-breed technologies customers demand. Robust security. Using a robust security solution to continuously monitor users throughout their entire session is the only way to cover as many security vectors as possible. Continual visibility. Sharing visibility of key events such as changes to account lifecycle or user attributes proactively protects it from any threats. I thought it was worth finishing off with a little quote by saying that in summary, balancing privacy and security is critical to the acceptance of continuous authentication. It's not a panacea to all authentication issues, but it's better than what a lot of people are using today, such as outdated passwords or 2FA. Thanks for your time. If you have any questions, please type them into the question box, and I'm happy to answer them now. Thank you.